Hello everyone. I am Uttam Satpute, Professor Electrical Engineering Department at DY Patil College of Engineering, Sanagar. This is video number 7 on traction moment and energy consumption of the subject electrical generation utilization of 8th semester. In this video, we shall solve some numericals on the tractive effort, what we have find out the previous equation. So this is the equation we'll have to remember the tractive effort to 277.8 WE alpha 98.1 WG plus WR. So as we will solve this problem in the three steps as we seen in the previous video. First, we will write down the given data, what data are given in the problem, and then we will write down what we have to find out. Okay, so I will take it as third step, find what we have to find out, and in between these two data given and find out, we should have an equation. We should know what equations we are going to use. So let us write down the data what are given. So you can see here the electrical train weighing 200 tons. So W is given here. So W is given 200 tons. Okay, has 8 motors geared to driving vehicle. Each wheel is 90 centimeter in diameter. So D, what it is given diameter, D diameter 90 centimeter. So we have to write it as 90 meter because all units should be in your SI units. Okay, then MKS. So then we have determined the torque developed by each motor to accelerate the train to a speed of 40 kilometer in 30 seconds. So now this is given as alpha value. Alpha value we have to find out. So the alpha it is 48 kilometer per hour in 30 seconds. So per second you have to divide it by 30. So it will get converted into kilometer per hour per second. Okay, we want alpha, it is in kilometer per hour per second. Okay, then gradient of 1 in 200. So we are given g value, value it is given as 1 by 200 into 100 we have to do because it is given in percentage. So g we have to calculate it in percentage, and then we have given attractive resistance is of 50 newton 50 newton per ton. So here we are given the value of r. R is given as 50 tons, 50 Newton per ton. So these are all the data given. Now what we have asked, the tractive effort, determine the torque developed by each motor. Torque we have asked. So torque, that is output torque. So we have already derived this equation. We will see torque we have to find out. So I will just note down the equations here, what we are using previous. The torque, what we have using it here, it is I think 2 uh, uh, okay, so I think we have used this F we have find out the tractive effort required to drive. It is given as 2 into T divided by D into sigma into efficiency. Okay, the other data are given. I forgot the effect of rotational inertia is 10% of the train. So this is given as a 10%. So WE. So WE to find out WE effective weight. So we have to multiply. This is given as 10%. So we have to. This is what we have to find out 1.1 into W weight we have to take, and then the gear ratio is 4 to 1. So gear ratio is given as sigma. It is given as 4 to 1. 4 to 1. So I think we have to use it as 4 divided by 1, and efficiency is also given, that is efficiency of the gear system, it is 80%. So all these values are given. So this is the equation what we have to use. We have to find out this torque T, what we are required T. Okay, so this torque we have to find out. So to find out this torque, we have to first find out this Ft. So Ft equation, it is this what we have to use here. So here 277.8 into 200. So We which is here I have written it is 10 per 1.1 into W. So you will get this alpha, it is as I told, alpha it is equal to 48 divided by 30 will give you the value of alpha. Okay, and then 98.1 W is already given. G, as I told, it is 1 divided by 200 into 100, so that will give you the G value. W, it is already given 200 tons into R is also given, so you can find out the torque, we can find out the tractive effort, and then we can substitute here. This gear ratio is given and efficiency is given, diameter of the vehicle is given, so you can find out this torque. So this is how we have to only use these two equations, one for the tractive effort and one for the torque. Okay, so this is how we can solve this problem. The second problem I have taken it here. It is similar sort of problem. So here let us write down what are the inputs given. So W is given the weight of a 200 ton motor coach having four motors, each developing 6009 Newton meter torque during acceleration. So the torque is given, the W is given, it is 200 ton. Okay, so it is weight of the train is 200 ton, 200 ton. It is given here, and diameter of the driving wheel it is 2 into 45. I think 45 is centimeter wheel radius. It is given in centimeter, so we have to convert it into meters radius. So to calculate diameter, it is multiplied by 2. Percentage G, percentage gradient is given as 30 divided by 1000 into, I think where it is given gradient percentage. Yeah, here it is given 30 in 1000. So 30 divided by 1000 into 100, we have to find out the gradient percentage. Tractive resistance is given as 50 Newton per ton. Gear ratio is given by 4. I think it is gear ratio. Here it is given, yeah, gear ratio is given as 4. Okay, and efficiency is 90%, equivalent exert. So here it is effective weight is calculated, which is 10% more than the weight, so 220 tons. The total torque developed is 4 into 6000. So 4 into 1000 is because there are four motors, so it is total tractive effort, torque it is this much. Now what we have to find out here, find the current during the notching period. Okay, so to do that, we have to first find out, I think, the torque is given. So from the torque, we can find out the tractive effort, and from the tractive effort here, alpha is calculated. So acceleration is not given. So from that acceleration is calculated, and from the acceleration, the time taken for the train to attain a speed of, so time is calculated. So 24.82 seconds, and then power output, as we have derived in the previous equation, force into velocity will give the power. So force into velocity will give you the power, and then power output divided by the efficiency of the motor, it is 85%. So we'll get the power input, and power input into 1000 voltage, I think it is given as 3000 volt. Okay, so divided by 1000 we'll get 1046 amps of current drawn per motor divided by 4, it is 261.4 amperes. This is very quite interesting problem, because we are dealing with the motor. Okay, so up to this only in this video. We shall continue in the next. Thank you.